Hi, in this video, we are going to learn about enantiomers and chiral molecules. So, we know that enantiomers are those stereoisomers whose molecules are non-superposable mirror images of each other. Means, if in a molecule around a carbon atom there are different groups and such that the two compounds which have same groups but they are mirror images of each other, and when we try to superpose those mirror images over each other, then those mirror images are non-superposable. Then we say that these compounds are enantiomers. These two compounds are enantiomers of each other. So let us see now some properties of enantiomers, that enantiomers always have possibility of existing in pairs. Now, as we are very well aware that stereoisomers have optical activity, means they try to rotate the plane polarized light into any direction. So generally, if enantiomers are mirror images, then one mirror image will rotate the plane polarized light into right direction, then other mirror image will rotate it in the left direction. So these two pairs, generally enantiomers exist in two pairs, though in many cases the stability of one of the mirror image is less, but still they occur in a pair. And also enantiomers occurs only with the compounds whose molecules are chiral, as we have seen that if the compounds mirror images are superposable, then we say that these molecules are chiral. And if non-superimposable mirror images are there, then we can say that these molecules are chiral, and ultimately those two compounds are enantiomer of each other. So to identify enantiomer, we need to recognize a chiral molecule in a compound, a chiral molecule or a chiral carbon in a compound. So how do we recognize a chiral molecule? So the answer is that a chiral molecule is one that is not superposable on its mirror image. And we are learning this definition from the very start of this video, that enantiomers are the compounds which are mirror images of each other and non-superposable, and similarly chiral molecules are the one which are not superposable on its mirror image. But we can understand this this fundamental with the example of 2-butanol. Here we can see that in 2-butanol, the second carbon or the carbon at which the alcohol group is attached has four different groups around it. That here it is CH3 group or methyl group, here is the OH group, here is the C2H5 or ethyl group, and one is hydrogen. So this is what is a chiral carbon, as we can see that there are four different groups around it. So now see, these there can be two arrangements where in first arrangement the hydrogen is out of plane and behind the plane of paper, and OH is coming out of the plane of paper, and in the other arrangement this is reversed. This is the same, but we can see that if we draw a mirror here, then we can see that these two form are mirror images of each other. And if we look at the ballistic model, then we can see that these are the representation of these two molecules, and if we try to superpose these two, we can see that these cannot be superposed, as there is OH group in front of OH group, H group in front of H group, but in front of CH2 CH3 group there is CH3 group, and similar case here also. So these are non-superposable mirror images of each other, and hence these are the enantiomers. Now, if a single chirality center is present in a molecule, then it is definitely a chiral molecule. And how to identify a chiral center? If any carbon has four different groups attached to it, then it is a chiral center. But remember, there must be a single chiral center. Then we can say with only this single criteria that if there is a four different groups attached to carbon, then it is a chiral molecule. But if there are more than one chiral center in a molecule, then there are chances that this molecule is not chiral, and then there are molecules which have which do not contain a chiral center that are chiral too. So remember this fact that if there is only a single chiral center in a molecule, then that molecule is chiral definitely, but if there are more than one chiral center, then there may be chances that that molecule can be a chiral molecule not. So this is all about enantiomers and called chiral molecules. If you have any query, please ask us. Kailasha Foundation Fun and Learn portal, always happy to help. Thank you.